We present a new generative adversarial network method applied to terrain authoring with spatialized style. We intuitively define style as a user's perception of the overall quality and common characteristics of terrain, or a particular category of terrain with similar elevation and landmark characteristics. Style exists at multiple scales, from large-scale geographic structures of hundreds of kilometers to landforms of a few meters. A key observation is that style has an enormous impact on the perception of a terrain. A highly irregular mountainous landscape from the Karakoram looks radically different from smooth hills in the Appalachians. Existing methods generally do not include the notion of style. Our contributions are a novel terrain model using a StyleGAN architecture that describes and generates high-quality digital elevation models, a set of tools, adapted to the model, that are central to terrain authoring. We introduce the concept of terrain style at different scales and spatialized, enabling rich context-aware content generation. We introduce a deep neural model based on the StyleGAN architecture and applied to digital elevation models. The user provides a height field as input. This can be a high or low resolution terrain or even a sketch. The input is fed into the encoding process to produce a latent vector representation and feature maps. Finally, the generator synthesizes a new terrain. The user can modify the latent space to control the generation process, or directly edit the result and feed it back into the encoder. This process is iterative, with rapid feedback and interactive response from the system. Latent and feature spaces allow a terrain input to be reproduced with a varying and controlled degree of fidelity. The input terrain is encoded into the latent space and feature maps. We can choose a specific level of feature maps to augment the fidelity or, conversely, increase the number of generated content and thus creativity. This pipeline allows the user to add detail onto a low-resolution terrain or sketch, thus creating a precise and coherent terrain. Starting from a sketch or low-resolution terrain, in Creativity Features mode, our model allows the user to add a lot of details onto the terrain. An important feature of our approach is that terrain consistency is maintained automatically. There is no need for the user to check the consistency of the changes. In this example, our model automatically corrects the unrealistic features that have been introduced by a copy and paste operation. This is an example of a user interaction. Our model is implemented as an add-on for Blender. The user can sketch a low-resolution terrain and our model will exploit the inference capabilities of the encoder to generate consistent and high-resolution output. From an initial terrain, we start by using the encoders to extract the latent vectors, as well as the feature maps to localize the style. On a second terrain, we calculate only the latent vectors. Then, we use the generator to mix the style of terrain 2 with the style of terrain 1 according to a mask. We begin by iteratively generating the data for the two terrains at a specific resolution and with a different latent vector. We will iteratively add details to the initial downsampled terrain. To do this, the feature maps are combined and mixed with a mask before using the to_dem operator to obtain the corresponding details. And so on to obtain the final terrain. Here is an example of a style added to a terrain globally, or in a localized manner. Here we show an example of a partial style modification over an input sketch. Afterwards, we select the entire map to apply the style over the whole terrain. The process is similar to modify the style of a real digital elevation model inverted by our method. These are examples of results obtained by non-expert users in less than 5 minutes. Thank you for watching.